Baseball is a sport that is very reliant on physics. Very small changes in how everything plays out create a large change in the final result. I'm primarily looking into how a baseball travels and how it's affected by factors controlled by the swing and factors controlled by the environment. In this experiment, I've also hired a man named Nixon Gabrick, aka Lil Thick, known as the Laker or the Buffalo.
Oh
We
my!
went to a batting cage, obviously, for the name of science, of course, but in reality, outside of us goofing off at the simulator, I recorded 5 of Lakers' swings, and the goal is to determine how variables such as launch angle, exit velocity, all that stuff influence a total distance that baseball travels, and I wanted to answer my personal related hypothesis. Can Laker hypothetically hit a home run in a major league ballpark under perfect conditions? You will have to find out. Before I go into the swings, we did our experiment at a place called Dinger's Batting Cages in Lloyd, and it uses a system called HitTrax, which calculates exit velocity and launch angle really well. But it will differ from the projectile motion calculations we were given in physics because it takes into account real world stuff such as air resistance and spin and all that stuff that projectile motion calculations do not account for. A more accurate prediction for projectile motion would require stuff like measuring spin rate, spin axis, and aerodynamic forces such as drag and resistance, which I can't do for a video recorded in 60 frames. And grounders are also going to be projected to go further when using HitTrax because it tracks the total distance that the ball rolls instead of where it hits the ground from, where like something projectile motion tracks.
On Laker.
Swing 1 has Laker starting on fire, hitting the ball at 92.5 miles per hour. If he hit this every single time he put the ball in play, he would be 20th overall in Major League Baseball on average exit velocity. Despite this great exit velocity, the ball barely gets over 35 feet in projected horizontal distance and 3 feet in vertical distance. Why? A launch angle of 6 degrees. When pulling up similarly hit balls at the Major League level, the ball rarely leaves the infield due to the short time that it's in the air. And here's a video of an
Think about trying to steal a base. He leads the team with
a similar
6
ball
this
to
year.
what, like Laker hit.
That ball hit hard by Cesar Salazar, but it's
right
caught on the
baseman.
line by Josh Naylor for the final out of the inning.
And this is what the projectile looks in Desmos. This rectangle, like this blue rectangle at the very right of the screen, that's what you need to hit a guaranteed home run. And yeah, some ballparks are shorter than others, so I only use what's hard enough to be hit to be a home run in every single ballpark.
Oh my god, go exit Holy shit.
Swing 2 is another flat shot at 4 degrees. This one's slower at 90.6 miles per hour. HitTrax distance of 111 feet and a projected distance of 77 feet. This difference is likely due to the ball rolling all on the ground. And this ball actually had a maximum height of only 1.3 feet, so do better, Laker. You have to get it over the fence.
That was good launch.
Swing 3 produced by far the most distance yet, although the lowest exit velocity. How does that work? The launch angle of 19 degrees is much higher than before, and with this shot being the furthest yet, Laker has officially made it out of the infield. None of these come close to the wall yet, but it is progress. This is what this looks like in game. Laker actually reached his base this time. He actually gets a hit, so
right center
good job
field.
on him.
Oh my god, 91.7. Oh my god.
Swing 4 had good exit velocity at 91.7, but the launch angle was only 2 degrees. It traveled 80 feet in HitTrax, but this was almost certainly because the ball hit the ground and then rolled. The projected distance was 39 feet with the projectile equation, and the height was 0.3 feet, which is barely anything.
Oh my.
That's good. Oh my god.
327. Laker.
Swing 5 had a similarly low exit velocity to Swing 3, yet it produced the most distance at 327 feet in hit tracks. Using the projectile motion equation, the projected distance was 412 feet with the maximum height of 52 feet. This swing undeniably proves that launch angle is the king of distance. It's a very similar exit velo to the third swing, but the 8 extra degrees of angle carried it much further and gave it a much longer air time. Now, despite this ball reaching the deeper part of the field, Lakers is still about 10 feet short of hitting over the fence.
Into left field, and that will fall for a base hit. Rounding first and heading towards second is Fernandez, and he's in with a stand-up double.
So why doesn't Laker just add more launch angle if adding more launch angles increasing its distance every time? Well, here's why. This is a swing with 96 miles per hour and a 76-degree launch angle, the fastest yet and the highest launch angle yet. This is going to be it. This is going to be a home run, isn't it? And it's a simple
Sky-high pop-up. Garcia, Diaz. Garcia makes the call on the catch.
So what exactly happened? A high launch angle isn't always better. Sure, it does increase the time the ball spends in the air, but it causes the energy to be transferred to the ball going upward rather than outward. Distance depends heavily on how fast the ball moves forward, which is why a high launch angle ball can always travel a shorter distance if it stays in the air longer than a shorter launch angle. Now, according to projectile motion, hypothetically, you'd want 45 degrees for hitting a baseball, right? But this isn't exactly true in the real world because the physics equation assumes a perfect environment without variables like air resistance. At 45 degrees, the velocity is evenly split between horizontal and vertical components. More energy is directed upward compared to a lower launch angle. More of the ball's velocity is directed upward, reducing horizontal velocity and making the ball more affected by drag because it stays in the air longer than one hit at 35 degrees. This one has more forward motion, making it less susceptible to the effects of drag than the 45 degrees. Drag is a force that acts opposite to the direction of motion that an object is moving towards. This chart shows the effect of drag on MLB four-seam fastballs thrown from 2016 to 2025. Higher CD means more drag, which slows the ball down faster. Lower will let the ball keep its speed for longer. And if you look at this chart, in 2019, fastballs thrown lost a lot less speed from drag compared to other years. If you want to hit a home run, drag is something you can't really control. Harder hit balls spend less time before reaching the fence, so they're desirable in reducing drag, which is another reason this 25 to 35 launch angle is optimal to prevent it while keeping the ball high enough to go over the fence. Another variable is backspin. Having backspin means the top of the ball rotates backwards relative to the direction it is traveling. Backspin matters because it creates something called the Magnus effect. And the Magnus effect is where the spin on one side of the ball slows down airflow on the other side, and it causes it to speed up. This creates a pressure difference that causes the ball to move. Here's a baseball that's hit at 95 miles per hour exit velocity with a 28-degree launch angle and 0 backspin. It travels 368 feet and hangs in the air for 4.4 seconds. Now here's one with the same exit velocity and launch angle, but 2,200 rounds per minute of backspin. This one travels 381 feet and is in the air for 5.1 seconds. Looking at this website, you can also see that wind and temperature affect the distance of a baseball. And hot air is less dense than cold air, which means there's fewer air molecules and drag that will hit the baseball. And so it travels further in hot air because it keeps more of its speed for longer. And wind also changes how the baseball moves relative to the air. If a baseball is hit at 100 miles per hour with a 30 mile per hour wind blowing towards center field, the ball only feels 70 miles per hour of airflow. A wind towards home plate increases the amount of drag and deceleration that a baseball faces. And then these crosswinds can change a home run to a foul ball, or foul ball to a home run if you're Aaron Judge in the playoffs. You can also change the park. You can see I have it set to Boston right now. This is only 21 feet above sea level and 406 distance, but if we change it to Colorado, it goes to 416 because this is a mile-high stadium and the air's a lot less dense over there, so it travels a lot further in Denver than Boston. A common saying me and Barry Bonds once said is the faster comes out of the hand, faster comes off the bat. Pitch speed is a factor because momentum and energy transfer during the collision between the bat and the ball. When the bat hits the ball, the bat redirects the momentum the ball already has. Because the faster pitch carries more momentum into the collision, the bat has to cancel the incoming momentum and reverse it the other direction. This is why hitting a 95 mile per hour pitch and a 100 mile per hour pitch the same way can produce very different exit velocities. The bat transfers over 13 kilograms meters per second of momentum in about like 1 millisecond. And I'll show you 2 home runs off very different pitch velocities.
Thought he almost had that thing.
Position player for
Leday sends one to deep right field, and that will leave the yard. Back-to-back home run.
And I'll show my 3rd favorite home run ever.
1 and 2.
Mason Miller throws 104 miles per hour.
Gurriel!
And Gurriel sends it deep.
Left field, and we're tied! He got him!
Now, hypothetically, knowing that Laker can hit a baseball 93 miles per hour, can he hit a home run under the perfect conditions? Here's a ball hit at 92 miles per hour with a 33-degree launch angle.
An ERA, 3.02. And in the air to right, and a home run off the foul pole. For
Yes, he can. Only 3.7% of these balls hit at these exact conditions are home run, but I think that's good enough for Nixon. So yes, hypothetically, Nixon Gabrick is able to hit a home run in a major league ballpark. What this experiment has proven to me is that hitting a baseball harder doesn't always guarantee more distance. It does give it more energy, however the launch angle determines that if energy is used horizontally or vertically. Laker hit several line drives that were very powerful off the bat, but without the correct launch angle, it prevented him from attaining the goal in my hypothesis, which is to hit for distance and to get a home run. And this is evident because his best swing, which was one of his slowest exit velocities, but the launch angle carried it over 200 feet further than his fastest swing. These results also proved why this projectile motion equation isn't always accurate, as variables such as drag, spin, wind, and air density are not accounted for. Thank you for watching.